All right, number 5, evaluate the integral using trigonometric substitution. So this is one where we actually want to draw a triangle and substitute the square root in there. So I'm going to start with the triangle. Even though there's this x squared on the bottom with the square root, we're only concerned about this square root part right here. So we're only going to use that to set up our triangle. And so based on how we've been setting up triangles, we know our hypotenuse is going to be x. We'll have the vertical leg be x squared minus 4, and we'll have the horizontal leg be 2. All right, so setting this up, if I want to solve for x, the first thing that I'm going to get to solve for x, that would be secant. So it's going to be secant theta equals x over 2. And if I solve cross multiply, I'll get x equals 2 secant theta. So dx, the derivative of that would be 2 secant theta tangent theta d theta. All right, now we want to solve for the square root, so I'm going to use tangent for that one. So we'll have tangent of theta equals the square root of x squared minus 4 over 2. Again, if I cross multiply, I'll get that the square root of x squared minus 4 is equal to 2 tangent theta. Okay, now from here, we are going to go ahead and plug things into our integral. So first of all, I want to plug in dx. Well, we found out that dx is 2 secant theta tangent theta, d theta, over, then we need an x squared. Well, we know what x is, so x was 2 secant theta. We're going to square that. And then the square root of x squared minus 4 was equal to 2 tangent theta. All right, so I'm going to go ahead and cross out what I can. I can cross out these 2's, I can cross out these tangents, and I'm just going to rewrite this just for a second. This would be like secant theta d theta over 4 secant squared theta. The 2 has to be squared as well as the secant, and now I notice I can cancel one of the secants, so I'm going to be left with d theta over 4 secant theta. I'm going to pull this 4 out front, so this is going to be 1/4, and 1 over secant is equal to cosine. And now this should be a pretty easy one to take the integral of. The integral of cosine is just sine, so it's going to be 1/4 sine theta. And then if you look up sine on our triangle, sine is opposite over hypotenuse, so this is going to be 1/4 times x, the square root of x squared minus 4 over x, and then if I just put that together, it will be the square root of x squared minus 4 all over 4x plus c, and that will be my answer. All right, number 6, evaluate the integral dx over x squared minus 6x plus 13. The first thing that I want to try to do is see if it's a partial fraction problem. So see if I could factor that. I notice I can't factor that. So the next thing that I want to think of is seeing that if I could complete the square, which I do think I'll be able to do. So I'm going to change this to x squared minus 6x, leave myself a spot, plus 13. Remember, for this, we're going to divide the middle term by 2, which would be negative 3, and square it. So that will give me plus 9 on the inside, which means I have to put minus 9 on the outside. And then this will factor as x minus 3 squared. And remember, once you divide, when I took negative 6 divided by 2, it was negative 3. That's what's going to go inside there. And then plus 4. So now this problem looks like dx over x minus 3 squared plus 4. And this is definitely now an arctangent problem. The u would be x minus 3. The du would be 1 dx, which I have. And then my a is going to be 2. So it's all set up to do an arctan. So arctan is 1 over a, so it's going to be 1/2. Arctan u over a, so it'll be x minus 3 over 2, and then plus c. Okay, number 7, the integral of x cosecant squared x dx. This definitely looks like a integration by parts. So I'm going to let u equal x, which means du will equal 1 dx. And then dv will equal cosecant squared x dx. The integral of cosecant is negative cotangent x. Hopefully you're familiar with your formulas. Now I'm ready to set up my integration by parts. It's going to be u times v, so negative x cotangent x minus the integral of v du, so negative cotangent x dx. First of all, those are going to change to pluses. So I'll have negative x cotangent x, and then again, as long as you're familiar with your formulas, you'll be fine. The integral of cotangent x is natural log of the sine of x, and then plus c.